When solving a system of equations, the goal is to take these two linear functions and find their intersection point. So there's three methods of doing it, and the first one is graphing. So I want you to follow along with me with your graphing calculator, so go grab that. And I want you to put the first equation, 2x plus 5, into y1, and negative x minus 4 into y2 in your calculator. Okay, so this is the format, this is how it should be set up and look in your calculator when you press y equals. Notice that my plots are not on because we're not graphing scatter plots, we're just graphing two lines. So the next thing I want to do is hit graph, and if you don't see the whole thing, you want to hit zoom 6 so that you have a 10 by 10 axis. So that top right picture is what your calculator should show. So the steps in finding the intercept is you're going to hit second and then trace. Alright, so second trace is my calculate screen. So then you're going to go down to number 5 and hit enter, or you can just hit the number 5 because at 5 it says intersect. So when you do that, it's going to, at the bottom, it's going to ask you a question. It's going to say first curve, and essentially it just wants to know what line. So get as close as you can to the intersection point. Hit enter. It's going to say second curve. Hit enter again. Guess. It always has you guess for some reason. And then I want you to hit enter for a third time. And when you do that, it should actually say the word intersection. So if you take a look down at the bottom, it says intersection x equals -3, y equals -1. So your answer for this it is a point because two lines intersect at one place. So you need to represent it as a coordinate pair. So you need to write your final answer as -3, -1. And you're going to put parentheses in because it's a coordinate pair. So that's your final answer. Now, the moment that you go to the right or the left with your arrow cursors in your calculator, it's going to give you an estimated number, and it's not going to say intersection anymore. So for it to be the exact intersection point, it needs to say the word intersection right after you hit enter on the third time after you did second trace in number 5. Okay, so now we're going to look at how to solve a system by using substitution. So your goal with substitution is to essentially take either linear function, so either equation, the top one or the bottom one, get it equal to either x equal or y equals, and then you plug that portion in for either the x or the y that you substituted for. So the biggest key that you want to look for is a variable that's by itself. It's going to make it really easy to substitute. So in this case, in the second equation, y is by itself, so that's what I'm going to set equal to y. Now, again, it could be an x equals. It doesn't have to be y. I know we're used to y, but it doesn't have to be y. And it might not be this easy either. So it might just be any one that you decide to do instead of one that sticks out like this y does. So over here on the right, I'm going to rewrite it as a y equals, and to do that I had to subtract 2x from both sides. So it's the same equation, it's just set equal to y. So I'm going to rewrite the function, the top one, just so we can see it a little bit easier here. So essentially what we're going to do is, because -2x plus 9 equals y, we're going to take that whole function, -2x plus 9, and we're going to put it in for y in the first equation. So that's going to look like this. 3 times -2x plus 9, and then the rest of the top equation, -2x equals 11. So now that we have one equation in terms of one variable x, we can now solve for x. So to begin this, I'm going to distribute the 3, and I'm going to get -6x plus 27 minus 2x equals 11. I'm going to combine like terms and get negative 8x plus 27 equals 11. And then I'm going to subtract 27 from both sides, and I get negative 8x equals negative 16. Divide by negative 8, and x gives me positive 2. Now, if you remember when we solved using our graphing calculator, it was a coordinate point. We only have x, so now we need to find y. Well, the nice part about substitution is that we just substituted in for y. So now essentially what we're going to do is take our x equals 2 and substitute it in again to get our y value. So this is what it's going to look like. We're going to have negative 2 times our new x value, 2, plus 9. Negative 2 times 2 is negative 4, and when you add 9 to it, you get 5. So y equals 5. So again, we need to rewrite this. You cannot leave it with x and y boxed like this. You have to state it as a coordinate point. So the intersection point is 2, 5. So the only thing left to do with this problem is to check it. So what you want to do is go back to the original up here and take x and y and plug them back in. So you're going to have 3 times 5 minus 2 times 2, which should give you 11. Then you need to plug it into both of them when you check. So then you need to do the bottom one. 5 plus 2 times 2 equals 9. So that's the key part in when you check. You have to check both equations because 2, 5 might be a point on the first line that's given in your system, but it doesn't mean it's on the second one too. And remember, the intersection point is one point that lies on both lines, and there's only one intersection point with two linear functions. Okay, the last method of solving a system that we're going to talk about is elimination. And essentially, what you're trying to do is instead of replace a variable or substitute a variable with another function like we were doing in the substitution method, we're going to kind of combine the two while in the process eliminating one of the variables. Because remember, you can only solve an equation if it's in terms of one variable. So if you have one line, one equation, that means you can only have one variable you're solving for. So this one is considered an easy elimination problem, and we'll look at a little bit more of a moderate to harder one next. But the ultimate point here is that you're trying to form a zero pair, which means when you add two things together, they give you 0. And you're trying to do that with your variables. So right here we have positive y and negative y. So when you add those two together, you're going to get 0y. And that's the point. So this one is nicely set up for us. It's not always like that. Sometimes we have to do a little bit of manipulation. And sometimes even not all the x's and y's and constants align. So you have to make sure it's also set up like that, where all three things are on top of one another. Because to do this, what we're going to do is we're going to add down. And we always add down. We never subtract, we always add down. So when you do that, you have 2x plus 3x, and you get 5x. And then like we said, this is our zero pair, so that eliminates y. And then you have 9 plus 16, and you're going to get 25. So just by adding them down like it was given, we already eliminated y. We divide both sides by 5, and x equals 5. And we already have one variable solved for. So, like we did in the substitution problem where we took that x value, plugged it back in, and found the y, we're going to do the same thing. So, for this, it doesn't matter which one you plug it back into. And just for the sake of it, I'm going to choose the first one. So I have 2 times 5 plus y equals 9. So 2 times 5 is 10 plus y equals 9. Subtract 10 from both sides, and y gives you negative 1. Just like before, you have to write it as a coordinate point, 5, negative 1. It's always wise to check your answer. When you plug it into this first one, you should get 9. When you plug it into this second one, you should get 16. Okay, so this is a little bit more challenging of an elimination problem, and it could get even harder than this, but I'm only going to give you a couple examples for your notes. So again, you're trying to form a 0 pair. So the first thing that sticks out to me is that we have a positive and a negative y. But the issue is that if I were to add those down, negative 1y plus 4y is going to give me 3y, and that's not 0. So I need to make it 0. So what I can do is do a scale change and multiply this whole top function by 4, because I need y to have a coefficient of 4. Now, you don't have to eliminate the y's. It's the easiest thing to do since you have a positive and a negative already, but you could also eliminate the x's. And if you did that, you'd have to multiply the top one by, let's say, you'd have to multiply this top one by negative 2, negative 3, and the bottom one by positive 2, because the lowest common number that 2 and 3 make is 6. Now, that's a little bit more work than the first way I showed you, but again, what that would do is eliminate the x's. So in substitution, it doesn't matter which variable you substitute it for. In elimination, it doesn't matter which one you eliminate, because the final step is to go back and find the other variable that you didn't just solve for. So I'm going to go back to using 4 here because it is a little less work, and we are trying to find skills and methods that prevent us from doing more work than we have to. So if I multiplied this through by 4, I would get 8x minus 4y equals 36. And then what I'm going to do is write the second one. I'm just going to rewrite it underneath of it because remember, we need to add down. Okay, and when we do this, we get 8 plus 3, which is 11. So we get 11x, negative 4y and 4y, there's my 0 pair. And then you have 36 plus negative 14, and you get 22. Divide both sides by 11, x equals 2. All right, your final step. Take that 2, plug it into whatever one you want. Again, I'm going to go with the first one. And then I'm going to solve y. So I have 2 times 2 minus y equals 9. That's 4 minus y equals 9. I'm going to subtract 4 from both sides and get negative y equals 5. So y equals negative 5. Once again, we take our answer, we write it as a final point, 2 comma negative 5. We check, make sure it gives us what we want, and there you go. There will be some problems where I just give you a system and I say solve using any method that you'd like. So find one that you like to work with and that you can do pretty well and stick with it. But I will also expect you to be able to demonstrate how to do all 3 methods all together.